acids, bases, and salts. Introduction. Acid. Acid is a word derived from the Latin word acidus. It means sour. Usually, we call any substance that has a sour taste. Base. The substance that has bitter taste and slippery to touch. Salts. A substance which is formed as a result of the neutralization reaction between an acid and a base. The acids are sour to taste and turn blue litmus to red. Bases are soapy to touch and turn red litmus to blue. There are many natural material like litmus, extract of red cabbage, turmeric solution, and extracts of colored petals of some flowers contain dye molecules are weak acids or bases. These can be used as acid-base indicators to detect the nature of the solution for acidity or basicity. Chemical properties of acids and bases. Response of various laboratory substances with indicators. Procedure. Collect the following samples from the science laboratory: hydrochloric acid, HCl, sulfuric acid, H2SO4, nitric acid, HNO3, acetic acid, CH3COOH, sodium hydroxide, NaOH, calcium hydroxide, CaOH2, magnesium hydroxide, MgOH2, ammonium hydroxide, NH2OH, potassium hydroxide, KOH. Prepare dilute solutions of the respective substances. Take 4 watch glasses. Put 1 drop of first solution in each one of them and test the solution. Dip the blue litmus paper in the first watch glass. Dip the red litmus paper in the second watch glass. Add a drop of methyl orange to the third watch glass. Add a drop of phenolphthalein to the fourth watch glass. Observation. Observe the respective color changes. Sample solution: red litmus paper, blue litmus paper, phenolphthalein solution, methyl orange solution. HCl unchanged, turns to red, colorless, turns pinkish red color. H2SO4 unchanged, turns to red, colorless, turns pinkish red color. HNO3 unchanged, turns to red, colorless, turns pinkish red color. CH3COOH unchanged, turns to red, colorless, turns pinkish red color. NaOH turns to blue, unchanged, red or pink, remains yellow. KOH turns to blue, unchanged, red or pink, remains yellow. MgOH2 turns to blue, unchanged. Red or pink, remains yellow. NH4OH turns to blue, unchanged. Red or pink, remains yellow. CaOH2 turns to blue, unchanged. Red or pink, remains yellow. What do you conclude from the observation noted in the table? Conclusion. In low pH values, the indicators show red color and in high pH color is yellow. Which of sample solution are acidic and which are basic? Acids: HCl, H2SO4, HNO3, CH3COOH. Base: NaOH, KOH, NgOH2, NH4OH, CaOH2. Activity 2. Olfactory indicators. There are some substances whose odor changes in acidic or basic media. These are called olfactory indicators. Aim: to check the olfactory indicators. Required materials: onions, knife, plastic bag, clean clothes. Procedure: take some onions and finely chop them. Put the chopped onions in a plastic bag with some clean cloth. Tie up the bag tightly and keep it overnight in the fridge. Observation: check the odor of the cloth strips. Result: it is used as the acid indicator. Lab activity. Aim: to show the reaction of acids with metals. Required materials: test tube, delivery tube, glass tongue, candle, soap water, dilute HCl, zinc granules. Procedure: set the apparatus as shown in figure. Take about 10 ml of dilute HCl in a test tube and add a few zinc granules to it. We will observe the formation of gas bubbles on the surface of zinc granules. Pass the gas being evolved through the soap water. Gas-filled bubbles are formed in the soap solution, which rise into the air. Bring a burning candle near the gas-filled bubble. The gas present in a soap bubble burns with a pop sound. Result: only hydrogen gas burns making pop sound. So, we will notice that gas evolved is H2. Chemical reaction: acid plus metal gives salt plus hydrogen. 2HCl, which is in aqua state, plus Zn, which is in solid state, gives rise to ZnCl2, which is in aqueous state, plus H2, which is in gaseous state. Additional experiment. Repeat the above experiment with H2SO4 and HNO3. We observe the same observation of the HCl experiment. Conclusion. From the above activities, we can conclude that when acid reacts with metal, H2 gas is evolved. Activity. Aim. To show the reaction of bases with metals. Required materials: test tube, delivery tube, glass top, candle, soap water, sodium hydroxide solution, zinc granules. Procedure. Take about 10 ml of dilute sodium hydroxide solution in a test tube. Add a few granules of zinc metal to it. Warm the contents of the test tube. Chemical reaction. Base plus metal gives rise to salt plus hydrogen. 2NaOH plus Zn gives rise to Na2ZnO2 plus H2. Note: such reactions are not possible with all metals. Activity 4. Reaction of carbonates and metal hydrogen carbonates with acids. Aim: to show that all metal carbonates and hydrogen carbonates react with acids to give a corresponding salt. Required materials: 2 test tubes, sodium carbonate, that is Na2CO3, sodium hydrogen carbonate, 2-holed rubber stopper, distillate funnel, stand, dilute hydrochloric acid, delivery tube, calcium carbonate. Procedure. Take a test tube with 0.5 grams of sodium carbonate. Close the test tube with 2-holed rubber stopper. Insert a distillate funnel through one hole and insert a delivery tube through the other hole. Pour 2 ml of dilute HCl to the test tube A and test tube B with sodium hydrogen carbonate. Observation. Carbon dioxide is released from test tube A and B. Chemical reaction. Na2CO3 solid plus 2HCl aqua gives rise to 2NaCl aqua plus CO2 gas plus H2O liquid. Metal carbonate plus acid gives rise to salt plus carbon dioxide plus water. NaHCO3 solid plus HCl aqua gives rise to NaCl aqua plus CO2 gas plus H2O liquid. Metal hydrogen plus acid gives rise to salt plus carbon dioxide plus water carbonate. Result. All metal carbonates and hydrogen carbonates react with acids to give a corresponding salt. Neutralization reaction. Aim. To test the change of color in the reaction of an acid with a base. Required materials: 2 ml of dilute NaOH solution, phenolphthalein indicator solution, dilute HCl, that is hydrochloric solution. Procedure: take about 2 ml of dilute NaOH solution in a test tube. Add 2 drops of phenolphthalein indicator solution. Observation: it turns to red or pink color, that NaOH is a base. Experiment: add dilute HCl solution to the above solution drop by drop. Observation: pink color disappears due to the reaction of NaOH with HCl acid. Experiment: now add 1 or 2 drops of NaOH to the above mixture. Observation: pink color reappears on adding NaOH. Chemical reaction: NaOH plus HCl gives rise to NaCl plus H2O. Base plus acid gives rise to salt plus water. Result: this reaction is called a neutralization reaction. Activity: reaction of metallic oxides with acids. Take a small amount of copper oxide in a beaker. Add dilute HCl solution while stirring. Copper oxide dissolves in dilute HCl and the solution becomes bluish green color due to the formation of copper chloride. Equation: metal oxide plus acid gives rise to salt plus water. Result: this reaction is same as the reaction of base with acid, that is neutralization. Reaction of a non-metal oxide with a base. Take a small amount of calcium hydroxide. Add CO2 into it. Salt and water are produced. Equation: non-metallic oxide plus base gives rise to salt plus water. Result: it is a neutralization reaction. Procedure: prepare glucose, alcohol, hydrochloric and sulfuric acid solutions. Fix 2 iron graphite rods on a rubber cork and place the cork in a 100 ml beaker. Connect 2 different colored electrical wires to graphite rods separately as shown in figure. Connect free ends of the wire to 230 volts AC plug. Complete the circuit as shown in the figure by connecting a bulb to one of the wires. Now pour some dilute HCl in the beaker and switch on the current. Observation: the bulb starts glowing. Repetition: repeat activity with dilute sulfuric acid, glucose and alcohol solutions separately. Observations: the bulb glows only in acid solutions, but the bulb do not glow in glucose and alcohol solutions. Result: glowing of bulb indicates that there is flow of electric current through the solution. Acid solutions have ions and the movement of these ions in solution helps for flowing of electric current through the solution. Conclusion: the positive ion present in HCl solution is H+. This suggests that acids produce hydrogen ions H+ in solution, which are responsible for their acidic properties. In glucose and alcohol solution, the bulb did not glow, indicating the absence of H+ ions in these solutions. The acidity of acids is attributed to the H+ ions produced by them in solutions. Properties of bases. What do bases have in common? Using alkyls such as sodium hydroxide, calcium hydroxide solutions, etc., instead of acid solutions. Does the bulb glow? No, the bulb does not glow. What do you conclude from the results of this activity? Acids are good conductors of electricity and not bases. Do acids produce ions only in aqueous solution? Activity. Procedure. Take about 1.0 grams of solid NaCl in a clean and dry test tube. Add some concentrated sulfuric acid to the test tube. Observations. A gas is coming out of the delivery tube. If we test the gas with dry and wet blue litmus paper, there is no change in color. Chemical equation. 2NaCl solid plus H2SO4 liquid gives rise to 2HCl plus Na2SO4 solid. Conclusion. We can conclude that dry HCl gas is not an acid because we have noticed that there is no change in color of dry litmus paper, but HCl aqueous solution is an acid because wet blue litmus paper turned into red. Note the teachers. The climate is very humid. Pass the gas produced through a guard tube containing calcium chloride to dry the gas. The HCl gas evolved at delivery tube disassociates in presence of water to produce hydrogen ions. The absence of water dissociation of HCl molecules do not occur. HCl plus H2O gives rise to H3O plus Cl minus aqueous. Hydrogen ions cannot exist as bare ions. They associate with water molecules and exist as hydrated ions with each H plus attached by 4 to 6 water molecules. H plus H2O gives rise to H3O plus. Base dissolve in water. NaOH solid when combined with H2O gives rise to Na plus aqueous plus OH minus aqueous. KOH solid gives rise to K plus aqueous plus OH minus aqueous. NgOH2 solid gives rise to Ng square aqueous plus 2OH minus aqueous. On dissolving bases in water produce hydroxide OH minus ions. Bases are soluble in water, are called alkyls. All bases do not dissolve in water. BeOH2 is slightly soluble in water. Activity. Reaction of water with acids or bases. Experiment. Take 10 ml water in a beaker. Add a few drops of concentrated H2SO4 to it and swirl the beaker slowly. Touch the base of the beaker. The base is hot. Result. This is an exothermic process called as dilution. Strength of acid or base. Take dilute HCl in a beaker. Close it with a cardboard and introduce two different color electrical wires through the holes made on it. Connect a bulb and make the connection as shown in the figure. The same replacing dilute HCl with dilute CH3COOH, lactic acid. Observation. The bulb glows brightly in HCl solution, while the bulb intensity is low in acetic acid solution. Result. More ions are present in HCl solution, which is a strong acid, than in CH3COOH solution, which is a weak acid. pH scale. A scale for measuring hydrogen ion concentration in a solution is called pH scale. pH value of a solution is simply a number which indicates the acidic and basic nature of a solution. The pH of neutral solution is 7. Values less than 7 on the pH scale represents an acidic solution. The pH value increases from 7 to 14. It represents a decrease in H3O plus ions concentration or an increase in OH minus ion concentration in the solution. pH value of solution above 7 represents a basic solution. Activity. Acid, neutral, alkali. Strong, weak, weak, weak. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. pH value as shown by different colors in universal indicator. Serial number, solution, color pH paper, approximate pH value, nature of substance. 1. HCl, blue litmus. 3. Smaller than 7, acid. 2. CH3COOH, blue litmus. Lesser than 7, acid. 3. NH4Cl, phenolphthalein. 7. Salt. 4. CH3COONA, phenolphthalein. 7. Salt. 5. NaHCO3, red litmus. Greater than 7, mild non-corrosive base. 6. Na2CO3, red litmus. 10.5, mild non-corrosive base. 7. NaOH, red litmus. 14. Base. 8. Distilled H2O, phenolphthalein. 7. Neutral. 9. Lemon juice, blue litmus, 2.2 acid. 10. Carrot juice, blue litmus, 5 and 6 mild acidic. 11. Coffee, blue litmus, 5 mild acidic. 12. Tomato juice, blue litmus, 4 acid. 13. Tap water, phenolphthalein, 6 to 8 neutral. 14. Banana juice, blue litmus, 5 mild acidic. 15. Colorless erected drink, phenolphthalein, 6 to 8 very mild acidic or nearly neutral. 16. Saliva, before meal, blue litmus, 5.5 to 6.9 mild acidic. 17. After meal, blue litmus, 5.5 to 6.9 mild acidic. Activity. Procedure. Take dilute HCl in a beaker. Add 2 to 3 drops of methyl orange indicator to it. The solution color turns to red. Now take the same solution and mix antacid tablet powder. Observation. Check the color change. Result: the color of the solution turns to light yellow. Chemical equation: 2HCl plus MgOH2 gives rise to MgCl2 plus 2H2O. Family of salts. Procedure. Take a little of soil in a test tube. Add 5 ml distilled water to it. Shake the contents and collect the filtrate in a test tube. Result: using universal indicator, we can check the pH of the filtrate. Self-defense by animals and plants through chemical warfare. Bee sting leaves an acid which causes pain and irritation. Use of a mild base like baking soda on the stung area gives relief. Stinging hair of leaves of nettle plant, inject methanoic acid causing burning pain. A traditional remedy is rubbing the area with the leaf of the dog plant, which grows besides the nettle in the wild. More about salts. The neutralization reaction of base with an acid. Activity. Serial number, name of the salt, formula. 1. Potassium sulfate, K2SO4. 2. Sodium sulfate, Na2SO4. 3. Calcium sulfate, CaSO4. 4. Magnesium sulfate, MgSO4. 5. Copper sulfate, CuSO4. 6. Sodium chloride, NaCl. 7. Sodium nitrate, NaNO3. 8. Sodium carbonate Na2CO3. 9. Ammonium chloride NH4Cl. Salts having the same positive or negative radicals belong to a family. Example: NaCl and Na2SO4 belong to the family of sodium salts. Similarly, NaCl and KCl belong to the family of chloride salts. Activity: pH of salts. Salt: pH, acidic, basic, neutral. Sodium chloride 7. Hydrochloric acid, sodium hydroxide. Aluminium chloride 7. Hydrochloric acid HCl, Al2O3. Copper sulfate lesser than 7, H2SO4 CuO. Sodium acetate 7. Acetic acid, sodium hydroxide. Ammonium chloride 7. HCl, ammonium hydroxide. Sodium hydrogen carbo greater than 7, ammonia plus CO2. Sodium carbonate greater than 7, NaHCO3. Chemicals from common salt. Salts are the ionic compounds which are produced by the neutralization of acid with base. Salts are electrically neutral. There are number of salts, but sodium chloride is the most common among them. Sodium chloride is also known as table salt or common salt. Sodium chloride is used to enhance the taste of food. Seawater contains many salts dissolved in it. Sodium chloride is the predominant component and it is separated from these salts. Deposits of solid salt are also found in several parts of the world. These deposits of large crystals are often brown due to impurities. This is called rock salt. Beds of rock salt formed seas of bygone ages dried up. Rock salt is mined like coal. Common salt, a raw mineral for chemicals. The common salt is an important raw mineral for various materials of daily use, such as sodium hydroxide, baking soda, washing soda, bleaching powder, and many more. Sodium hydroxide from common salt. Electricity is passed through an aqueous solution of sodium chloride. It decomposes to form sodium hydroxide. The process is called the chlor-alkall process because of the products formed for chlorine and alkali for sodium hydroxide. Important product from chlor-alkali process: salt, H2, fuels, margarine, ammonia for fertilizers, Cl2, water treatment, swimming pools, PVC, disinfectants, CFCs, pesticides, NaOH, degrazing metals, soaps and detergents, paper making, artificial fibers, hydrochloric acid, bleach, Ca OCl2. For cleaning steel, ammonium chloride. Medicines, cosmetics, bleach. For household bleaches, bleaching fabric. 2NaCl aqueous plus 2H2O liquid gives rise to 2NaOH aqueous plus H2 gas. Chlorine gas is given off at the anode and hydrogen gas at the cathode. Sodium hydroxide solution is formed near the cathode. The third products produced in this process are all useful. The different uses of these products. Bleaching powder. The electrolysis of aqueous sodium chloride. This chloride gas is used for the manufacture of bleaching powder. Bleaching powder is produced by the action of chlorine on dry slaked lime CaOH2. Bleaching powder is represented by formula CaOCl2. Though the actual composition is quite complex, CaOH2 plus Cl2 gives rise to CaOCl2 plus H2O. Uses of bleaching powder. It is used for bleaching cotton and linen in the textile industry, for bleaching wood pulp in paper industry, and for bleaching washing clothes in laundry. Used as an oxidizing agent in many chemical industries. Used for disinfecting drinking water to make it free of germs. Used as a reagent in the preparation of chloroform. Baking soda. Baking soda is sometimes added for faster cooking. The chemical name of the compound is sodium hydrogen carbonate NaHCO3. It is prepared as follows. NaCl plus H2O plus CO2 plus NH3 gives rise to NH4Cl plus NaHCO3. Baking soda is a mild, non-corrosive base. 2NaHCO3 when heated gives rise to Na2CO3 plus H2O plus CO3. Uses of washing soda. Sodium carbonate is used in glass, soap and paper industry. It is used in manufacture of sodium compounds such as borax. Sodium carbonate has a cleaning agent for domestic purpose. It is used for removing permanent hardness of water. Removing water of crystallization. Procedure. Take few crystals of copper sulfate in dry test tube. Heat it for a few minutes. The salt turn white in color. Observation. We notice water droplets on sides of the test tube. This shows that crystals of salts are not really dry. Add 2 to 3 drops of water on the sample of copper sulfate obtained after heating. Result. The blue color of copper sulfate is restored. Plaster of Paris, CaSO4, half of H2O. On careful heating of gypsum, CaSO4 to H2O at 373 K, it loses water molecules partially to become calcium sulfate hemihydrate, CaSO4, half of H2O. This is called plaster of Paris. The substance as plaster for supporting fractured bones in the right position. Plaster of Paris is a white powder, and on mixing with water, it sits into hard solid mass due to the formation of gypsum. CaSO4 half H2O plus 1 half H2O gives rise to CaSO4 to H2O. That is plaster of Paris to gypsum. Note: half of a water molecule is shown to be attached as water of crystallization. It is formed because two formula units of CaSO4 share one molecule of water. Plaster of Paris is used for making toys, materials for decoration, and for making surfaces smooth. Try to collect the information for calling calcium sulfate hemihydrates as plaster of Paris.